Welcome to the mathematics in my channel. Today we are going to solve another interesting integrals. Okay, there are 5 integrals. Integral from 0 to 1, x to the x, x to the minus x. Also we know these two integrals we called Sophomores Dream. Okay, here next one, integral from 0 to 1, x to the square root of x. Here square root of x raised to the square root of x, and here 0 to 1, x raised to the x raised to the 3. Okay, we know these integrals all are same type of integrals. So if we evaluate the general case, we can easily integrate these all integrals. Okay, first I'm going to take x to the m x to the n. Okay, then we know this is equal to e to the m x to the n times natural log of x, because we know x is equal to e to the natural log of x. Okay, then we know e to the x, we can write 1 plus x over 1 factorial plus x square over 2 factorial plus so on. Therefore we can write x raised to the mx raised to the n is equal to e to the here mx raised to the n times natural log of x, and according to this we can write this is equal to 1 plus, now instead of x we can plug in mx raised to the n times natural log of x. So here m x to the n natural log of x over 1 factorial, so we know 1, then plus x square, so m square x to the 2 times n natural log of x square over 2 factorial plus next term m raised to the 3 power x raised to the 3 times n power natural log of x raised to the 3 power over 3 factorial plus so on. Okay, then if we take integral both sides 0 to 1, x to the mx to the n dx, this is equal to, we know here dx, so 0 to 1 dx plus here we know m is a constant, so m times 0 to 1 x to the n natural log of x dx plus here m square over 2 factorial is a constant, so here 0 to 1 x raised to the 2 times n natural log of x square dx plus here m raised to the 3 power over 3 factorial is a constant, and here integral from 0 to 1 x raised to the 3 times n natural log of x to the 3 power dx. Sorry. Okay, now here plus so on. Now if we take these integrals, we know same type of integrals. So if we take the general case, we can write these integrals like 0 to 1 x to the a natural log of x to the b dx. Okay, now we are going to evaluate this integral. So now how to evaluate this integral? Okay, now we can use a substitution. So if we take for this integral, if we take u is equal to minus natural log of x. So we know natural log of x is equal to minus u, and x is equal to x is equal to e to the minus u. Okay, now we can differentiate. So here we know du is equal to minus 1 over x dx, and dx is equal to minus x times du, and here minus, we know x is equal to e to the minus u du. Sorry. And now if we take limit when x approaches to 0, we know u approaches to infinity. When x approaches to 1, upper limit, u approaches to 0. Okay, then we can write this integral. If we take this is equal to I, so we can write now I is equal to limit, we know limit now infinity to 0, so infinity to 0, x is equal to e to the minus u, so e to the minus u raised to the a times the natural log of x, we know minus u, so minus u to the b times, now here dx, so dx is equal to minus e to the minus u du. Okay, now we can simplify. So we can write, now we can change the limit 0 to infinity, so this minus get cancelled, and here e to the minus u raised to the a, here e to the minus u, so we can write this is equal to e to the minus u times a plus 1, and here minus 1 to the b times u to the b du. Okay, then minus 1 to the b is a constant, so minus 1 to the b integral form 0 to infinity. Now here e to the minus u a plus 1 u to the b du. Okay, now for this integral we can take another substitution. So if we take t is equal to u times a plus 1, differentiate, so dt is equal to a plus 1 du, and lower limit and upper limit also 0 to infinity. Therefore we can write, now this is equal to minus 1 to the b integral from 0 to infinity, here e to the u times a plus 1, we know u times a plus 1 t, so minus t times now u is equal to t over a plus 1, so t to the b a plus 1 to the b, and du is equal to dt over a plus 1. Okay, now we can write minus 1 to the b over here a plus 1 to the b plus 1 power times, we know this is equal to gamma of b plus 1 and gamma, okay, I rewrite gamma of b plus 1, and we know gamma of b plus 1 is equal to b factorial, so here we can write gamma minus 1 to the b power times b factorial over a plus 1 raised to the b plus 1. Okay, this is the answer for this general integral. Well, now we can evaluate our main integral. So we know here 0 to 1 x raised to the mx raised to the n, so we can write now 0 to 1 x raised to the mx raised to the n dx is equal to, now we know here 0 to 1 dx, so we know this is equal to 1, so therefore here now 1, and now it is difficult to move. Okay, now we have this integral, so here for this integral we know a is equal to, now a is equal to n and b is equal to 1, so a is equal to n and b is equal to 1, so we can write here this is equal to here m and here minus 1 to the b, so we know b is equal 1, so here minus m over, now a is equal n, so n plus 1 raised to the 2, so n plus 1 square. Okay, now for second integral, and this integral we know a is equal to 2 times n, a is equal to 2 times n and b is equal to 2. Okay, so we can write now here also here m square over 2 factorial is a constant, and then integral, so we can write here now a is equal to n and b is equal to, so here we know minus 1 square, so plus, so this is okay, and here 2 factorial, so 2 factorial over, and here 2 times n plus 1 raised to the 3 power. Okay, then now we can guess, so we can write here next term m raised to the 3 power over 3 factorial times 3 factorial over 3 times n plus 1 raised to the 4 power, then plus m to the 4 power over 4 factorial times 4 factorial over then here we know 4 times n plus 1 raised to the 5 plus so on. Okay, then here this is the general case, and we can simplify this, so 2 factorial get cancelled, 3 factorial also get cancelled, 4 factorial also get cancelled, and we will have integral from 0 to 1 x raised to the m x to the n dx is equal to now 1 minus m over n plus 1 square plus m square over 2n plus 1 raised to the 3 power minus m raised to the 3 power over 3n plus 1 raised to the 4 power plus m to the 4 power over 4n plus 1 raised to the 5 minus so on, also here minus. Okay, now our first integral we know first one our first integral 0 to 1 x to the x dx. Okay, now we can compare with these two integrals, so here now we know 1 times x, so m is equal 1 and n is also equal to 1, so now if we plug in m is equal 1 and n is equal 1, we will have the integral of 0 to 1 x to the x. Okay, now here we know for this integral m is equal 1 and n is equal 1, so we can plug in, so we can write here 1 minus m is equal 1, n is also equal to 1, so 1 over 2 square, then here 1 over n is also 1, so 3, so 3 to the 3 power minus here now 1 over 4 to the 4 power plus 1 over 5 raised to the 5 power minus so on. Okay, this is the answer for first integral 0 to 1 x raised to the x. Okay, now second integral. So we know second integral 0 to 1 x to the minus x dx. Now for this integral we know m is equal to minus 1, m is equal to minus 1 and n is equal to 1, n is equal to 1. Therefore we can plug in here. So here 1, then m is equal to minus 1, so this is going to plus 1 over, now n is equal 1, so 2 square. Here again plus 1 over 3 raised to the 3 power plus 1 over 4 to the 4 power plus so on. Okay, this is the answer for second integral x raised to the minus x. And now if we take third integral 0 to 1 x raised to the square root of x dx. Okay, now also we know now x raised to the 1 half, so we can write now m is equal to 1, m is equal to 1 and n is equal to 1 half. Therefore we can plug in here also 1 and then m is equal 1, so here minus 1 over, now n is equal 1 half, so 1 half plus 1, so 3 over 2, so 1 over 3 over 2 we know 2 over 3 square, so 2 over 3 square. And then here plus, now m is equal 1 and n is equal to 1 half, so 2, so 1 half, so we can write this is equal to 2 over 4 square, sorry, third power. Okay, then here 2 over 5 raised to the 4th power plus then 2 over 6 raised to the 5th power minus so on. Okay, this is the answer for integral of x raised to the square root of x. Okay, then number 4 integral from 0 to 1 the square root of x raised to the square root of x dx. Okay, now for this integral we know m is equal to 1 half and n is equal to 1 half, because here we can write x raised to the 1 half, here also here x raised to the 1 half. Therefore m is equal to n is equal to 1 half. So now we can plug in, so here 1, now m is equal to 1 half, so minus 1 half, and n is equal to 1 half, we know 2 over 3 square, so 2 over 3 square, then plus 1 half square times here 2 over 4 raised to the 3 power, and then minus 1 half raised to the 3 power 2 over, sorry, here 5 raised to the 4 power plus so on. Okay, this is the answer for fourth question. Okay, then our last integral number 5 0 to 1 x raised to the x raised to the 3 power dx. And now we know m is equal to 1 and n is equal to 3, so here we can write this is equal to 1 minus, now n is equal 3, so 3 plus 1, so 4, so 1 over 4 square plus 1 over 7 raised to the 3 power minus 1 over 10 raised to the 4 power plus so on. Okay, we are done. If you like this video, please subscribe this channel. Thank you for watching.